All right, back again. Wanted to do a quick tutorial on vacuum tubes. This here is vacuum tube for my ham radio. It's a 6146B tube. I just got a new set of these tubes in for my radio. Have not put it in yet, and just wanted to go over some basics. There are certain classes of tubes. One is your diode. Diode basically consists of a heater element, a cathode, and an anode. The heater element is generally left out of the schematic diagram, and only the active elements are shown, which would be, in this case, the cathode and the anode. Since there's two active elements, that's the reason why it's called a diode, di for two. And the diode functions as a one-way electron valve, the electrons migrating from the cathode to the anode. Basically, the heater element here, the heater, heats up the filament, which then releases what they call thermions. A thermion is just a fancy way of saying an electron which has been blown loose from its orbital by an excess of kinetic energy, forming an ion. The electrons congregate in the area of the cathode, and when there's enough potential difference, they migrate to the anode and a current flows. The next kind of tube is what they call a triode, tri meaning three. As you can see, there's three elements. There's a cathode, there's what they call a grid, and then there's an anode. The grid basically functions as a valve. By varying the potential on the grid, basically it repels the electrons and suppresses them from migrating across the gap to the anode. The big problem with this type of tube, triode, is that it has limited gain because of what they call the Miller effect between the grid and the anode. The Miller effect basically is a parasitic capacitance coupling between these two elements in the tube. What happens is as you vary the potential of the grid, it electrostatically couples to the anode, and that can cause a feedback oscillation, which can be a real problem. One of the ways of getting around this is to do what they call neutralize the tube, which basically means you feed back a portion of the signal 180 degrees out of phase, canceling that parasitic capacitance and rendering it basically neutralized. That's why it's called neutralizing the circuit. The next type of tube is called a triode. Triode, is a tetroid. A tetroid. Excuse me, that is a mouthful. Tetroids are basically a cathode, a grid, and what they call a screen grid. The screen grid is basically there to do away or to suppress or eliminate, but it doesn't fully eliminate the Miller effect. What it does is, like the name implies, it screens out the electrostatic coupling between the grid and the anode. The next type of tube is called and what the problem is here, the problem that develops using a screening grid, and that's to go to the next tube, is secondary emissions. In any type of tube, you're going to have, when the electrons strike the anode, they're going to release other electrons. And since the screening grid is so close to the anode and is at a negative potential, or is at a positive potential, slightly lower than the anode, it has a tendency of absorbing those electrons, and thus lowering the efficiency of the tube. Then so the pentoid, which is the next type of tube, has 5 elements, hence the pentoid. Cathode, grid, screen grid, and then what they call a suppressor grid. The suppressor grid is basically to form a potential and to kind of screen the screening grid from the anode. So it basically it dampens out the secondary emissions effect. It basically it keeps the electrons from flowing in the direction of the screen grid, and thus eliminates some of the problems with that is associated with the tetroid. And that's really about it. Another type that is basically like the 6146 tube that I have here is called a beam tetroid. And let me draw that real quick for you all. And basically what it has is it has a cathode, it has a grid, which is your control grid. It then has a screen grid. Remember, the Pentoid has a suppressor grid. This one has a screening grid. But then what it has is two little plates, which are called beam plates on the side. And they're usually at the same potential as the cathode. And the grids of a beam tetroid are basically aligned with each other. And what this does, these two plates, is funnel the electrons in a beam towards the anode. And that has the effect really of doing, it basically does what the Pentoid does, but is more efficient. So that's called a beam tetroid. That is what this tube is here, is a beam tetroid. So anyway, these basically, even though the beam tetroid does have a suppression, a screening grid, they do generally require neutralization, as does on my ham radio here. And the reason why that is because they are very, very sensitive to any type of feedback. And even though the screening grid does blank out or does eliminate a lot of the Miller effect, any type of regenerative feedback can cause oscillations. And that's why you generally neutralize the beam tetroid or a regular tetroid. So enough of my rambling here. If anyone has any questions, please give me a comment, and I'd be happy to answer them the best I can. So anyway, bye-bye.